Hello and welcome everyone to the Varsity Tutors Love of Learning series, where if you're like me, you spent a good portion of your winter break staring up at the night sky. We had Jupiter and Saturn aligning for the first time in 800 years, and the rest of the sky is pretty exciting. But also, if you're like me, even with binoculars or a telescope, it's kind of hard to tell that they were planets and not just bright stars. And so, for that reason, to help us better understand what we're looking at when we look at the night sky, we invited our friends from the Pacific Science Center. We've got Holly and Fatima here to get us up close and personal with some of the coolest planets and moons in our solar system, so we really understand what we're looking at when we look up. Now, before I turn it over to them to give us a tour of space, let me give you a quick tour of our section of cyberspace. This is designed to be super interactive. They're going to ask you lots of questions that we want you to answer. So use the chat panel to the right of the screen to answer their questions as they find out what you know and think about space. And if you've got any questions whatsoever throughout the class, use that chat panel to ask those. And in the last 10 minutes or so, I'll interview them with your questions so we can get everything you've ever wanted to know about our solar system answered. Also, make sure you've got a camera nearby because this is a field trip to space. We're going to give you some opportunities to take pictures coming up in about 15 minutes with one of everybody's favorite planets. We'll have a design selfie moment. And if you see other planets and moons you want a picture next to, feel free to lean into the screen and take a picture. And if you upload any of those pictures to Instagram and tag Pacific Science Center and Varsity Tutors, you'll be entered to win, and this is pretty cool, a field trip for you and up to 100 of your closest friends or classmates to space with Pacific Science Center. So make sure you've got that camera nearby and are ready to go. All right, with all that said, I think it's time to blast off on our field trip to space. So buckle in because I hear the G-forces are pretty intense. Fatima, I think you're up first. Take us to space.
Awesome. Thank you so much, Brian, and welcome everyone. I am so excited to be joining you all in our virtual planetarium today. Our program today is all about astrogeology, so a science that combines both astronomy and geology. So with part of this, we're going to be making a lot of observations about the geological features we can see on different places out in outer space. And today, we're going to be focusing more on our own solar system. So thinking of nearby planets and moons that we can find in our neighborhood of the Milky Way. And so for this, we're going to be using our virtual planetarium to visit some really cool places away from Earth. But before we venture off out into space, I would like to start us off a little bit closer here at home because we can actually see some of the places in our own night sky that we're going to be taking closer looks at earlier or in a moment here in our program. So I'm going to go ahead and bring us into our virtual planetarium so we can try figuring out where in our night sky to try to search for some of these things we'll be observing. So here we are right now in the planetarium. I do have it currently set to where I'm at here in Seattle, Washington, but just so for folks anywhere that you might be, no matter your location, you should be seeing pretty similar things in your sky as long as you're here in the Northern Hemisphere. If you're a little bit further north or south than I am, you might see that things are a little bit closer or further from the horizon, but for the most part, things will be in about the same spot. And right now here in the planetarium, I have us a little bit earlier in the day at about 9:30, so just a little after sunrise has started, but we can see the sun is still pretty low in our sky. And we're actually going to be using the sun here to help us with finding where in the sky we should focus our search for some other nearby things that we can see from our sky without needing any fancy tools, so no telescopes or binoculars like Brian mentioned earlier, being able to find some things here in our own dark skies. So to do that, what I'm going to go ahead and do is actually fast forward time a little bit here in the planetarium. And folks at home, what I would love for y'all to be doing is pay really close attention to the movement you see the sun appear to make in the sky. You might want to try getting a finger out so you can trace the path of the sun as you watch it move on your screen. And let's go ahead and get things started in here. So let's take a look at what happens. So as I start to fast forward time, we can see here the sun starts to rise higher and higher in the sky. So moving from over to the east until we get to about midday, which is when the sun is going to reach its highest point in the sky. And then if you're tracing at home, you might realize now it's starting to dip back down closer to the horizon as we're getting close to sunset in the early evening over in the west. Now, that path we just saw the sun take is known as the ecliptic. And if we back up a little bit, we know the sun itself isn't really moving, right? At least not enough for us to be able to observe in our lifetime. So that motion that we just saw the sun appear to take in our sky is actually showing our own planet's motion. So we think about our rotation on our axis, the thing that gives us day and night, as well as our orbit around the sun. And the cool thing about our solar system is all of the other planets are going to be completing their own orbits around the sun as well. And they're doing that on a pretty flat plane. So we don't have to worry about Jupiter, for example, floating up high into space in our night sky. Saturn's not going to be dipping down low, sinking to the bottom of our solar system. So because the planets are all orbiting on that flat plane, we can use the ecliptic here in our night sky to track down some of the visible planets we can see from here on Earth. So right now in the planetarium, if I, for example, come back over here to the east where we saw the sun start earlier in the day, and I look up a little bit higher from the horizon, up here high in the sky, I have this really bright object. And because it's so bright, that tells me it's probably a lot closer to the Earth than the other things we can see in our sky. I'm also noticing it's reflecting kind of an orangish reddish color light. So that tells me that it might have a really red surface actually. So enough red on that surface to reflect this color light. So I'm wondering if any folks at home might have any ideas of what could possibly be big enough to reflect this much light, close enough to Earth to be this bright in our sky, and have enough red on its surface to show up as this color in our sky. If you have an idea, this would be a great time to try sharing that in chat. Let me know. What do you think we might be looking at here? I'm seeing a few folks are mentioning maybe possibly looking at a planet. Some folks are maybe guessing Venus here. I'm also seeing a few folks mentioning Mars though. So our red neighbor out to the outer solar system. And folks who are thinking Mars right now, you were right. So right now, Mars is going to be one of the visible planets here in our sky. And we'll take a look getting a little bit closer at this planet in a little moment here. But for now, if I continue down that ecliptic, so that path we saw the sun taking, and I come over here towards the southwest, I can see a couple more really bright objects here that are super low to my horizon right now, and they're up pretty early. So it's about 5:15 here in the evening. And these two objects are also going to be planets in our solar system. Now, we can see they're still shining really bright as we saw Mars earlier, but these two planets are going to be a little bit further from Earth than Mars was. But because they're still shining so bright, that tells me these two planets are probably really big. And that might be a good clue for some folks at home who might now be thinking of our two gas giants, Jupiter and Saturn. Just like Brian was mentioning earlier, these two planets were recently in the news because Jupiter just actually passed Saturn in its orbit around the sun. So they got super close together, and they're still both visible in our sky right now. So hopefully that helps folks with getting kind of a start on the astronomy side of astrogeology. But before we fly out into space, I think it would be great to stick around here on Earth and actually send things over to my friend Holly, who can give us a little bit more information on the geology side, so we can start making some observations about some different geological features.
Awesome. Thank you so much, Fatima. It was so cool to be able to spot some of those planets in our night sky. I'm looking forward to looking for those later. But now that we've learned how to spot those planets in our sky, we're going to talk about how scientists study those planets. So go ahead and share with me in that chat panel. Do you have any ideas? How might we be studying those planets, moons, and other objects out in our solar system? What do you think? So geologists here on Earth are oftentimes able to just go directly to the places that they're studying, right? Walk right up to them. But the farthest away that we've ever sent a human into outer space is actually our own moon, just about 240,000 miles away. So how can we study things that are even farther out in our solar system than that? Well, we often use something called remote sensing, or taking measurements from a distance. And I'm actually seeing a lot of you, all of your suggestions that are coming in are great examples of remote sensing. So things like using rovers or landers, telescopes and satellites to take pictures and other scientific measurements of things out in outer space. So I'm going to give us a little bit of a challenge. We're going to take a look at a remote sensing image from here on Earth. So go ahead and share with me again in the chat. What do you think that this is an image of? Now, this image was taken by a machine orbiting Earth from space called a satellite. It's an aerial image, right? It's taken from the air, looking down on this landform. Oh, awesome. I see some great ideas coming in the chat. Glacier, mountain, volcano, crater. Someone said snow. Those are great guesses. So what we're going to do is we're going to now change our perspective to look at this landform from the point of view that we're used to seeing this landform from. Here we go. All right, so yes, indeed, it is a mountain, a volcano. This is Mount Rainier, located here in Washington State. Now, we're going to be taking a look at some more aerial images as we practice being astrogeologists. Just like Fatima said, those are geologists studying things in outer space, and geologists study things like minerals, rocks, and landforms. We're going to specifically be looking for those different types of landforms, so things like craters, valleys, mountains, volcanoes. All right, friends, here's your first challenge. So go ahead and take a look at these two pictures. One of these remote sensing images is from Mars, and one of them is from Earth. So go ahead and share with me in the chat, which one do you think is Earth? Number 1 or number 2? How well do you know your home planet? All right, once you've got that guess in, next I want you to think about what type of landform do you think we might be seeing in these two pictures? All right, I'm seeing actually a pretty good mix of both 1s and 2s. We might be kind of split 50-50 on this one. I'll go ahead and reveal the answers. So number 1 is here on Earth. This is Behringer Crater in Arizona State. And it was created by a meteorite, like I saw a lot of you guessing in the chat. A meteorite is a space rock that crashed down onto Earth. And this particular crater was created just about 50,000 years ago, which is actually pretty short in geologic terms. Now in the Mars image number 2, we can see a similar shape, right? That round circle in the upper right corner. So what do you think, geologists? Do you think that that shape on Mars might also be a crater created by a meteorite? And perhaps some of you might have noticed the river channels in that Earth picture. And I noticed kind of a similar pattern happening on Mars. Do you think it's possible that that similar pattern is caused by flowing water on Mars a long time ago? So these are exactly the kinds of questions that astrogeologists are looking for the answers to. So let's go ahead and do our second challenge. Again, one of these pictures is from Earth and one of them is from Mars. So again, share with me in the chat, which one do you think is Earth, our home planet? Number 1 or number 2? Once you've got your guess in, start thinking about what type of geologic landform you think might be showing up in these pictures here. All right, I see a few more 1s coming in this time. We'll see. And I see a lot of folks are guessing things like desert, sand, sand dunes. You all are right on track. So I'm going to go ahead and give us our answers now. This time, number 2 was actually Earth. So this picture, number 2, is showing us some of the tallest sand dunes here on Earth. They're actually in Namibia, located in southern Africa, and the tallest of these sand dunes is taller than 3 Statue of Liberties stacked on top of each other. And Mars actually has similarly sized, really large sand dunes. And you might notice on both of these pictures that it kind of has a reddish color, just like Fatima was saying as well. When we look up at Mars in the night sky, we see that reddish color. And in both Mars and Earth, that's caused by a chemical compound called iron oxide. But astrogeologists can also study the shape and pattern of these sand dunes to learn more about things like wind patterns on Mars and how the atmosphere circulates there. All right, folks, I've got one last challenge for you. So go ahead and share with me again, which one of these two pictures do you think is from Earth? Which of these remote sensing images is Earth? Once you've got your guess in, start thinking about what type of landform you think this might be. Awesome. I see lots of guesses coming in. Crater again, volcano, mountain, good ideas. Let's find out which one is which. All right, folks, so number one is Earth, and these are the Galapagos Islands, a group of volcanoes located in the Pacific Ocean near the equator, just off the coast of Ecuador. And the other image, number two, is Olympus Mons on Mars, and this is the largest known volcano in our solar system. So nice job, everybody. Now, even though we can't go out to these planets and study these geologic features directly, we can take what we know about the landforms and geologic features here on Earth and the satellite images, remote sensing images we have here on Earth, and go compare them to the things that we can see on other planets. So now that we know what some of these landforms look like, let's head back out into outer space to see if we can spot some of these geologic features out on a neighboring planet of ours.
Awesome. Thank you, Holly. Yeah, I think we're definitely ready to go ahead and fly out into space in our virtual planetarium. So I'm going to go ahead and bring us back in. Right now, I still have us here at home, though, so we haven't gotten too far. We'll fly off in just a moment, but I thought it'd be really nice to start off by trying to make some observations here of our home planet. That way we can use those observations to try and compare what we're seeing from here and some other places in our solar system. So folks at home, what are some observations you can make about what you're seeing here on the surface of Earth? What are some things you're noticing? Are there any particular colors or shapes? Are you seeing any signs of maybe some of those geological features Holly was talking about just a moment ago? I see a few folks in chat are mentioning the colors. I'm seeing a lot of blue, actually. Yeah, I agree. So we can see a lot of Earth's surface is actually going to be covered by water, right? So these giant oceans we have, and that water unfortunately does cover up a good amount of our surface, making it kind of a little tricky to make some observations of what our surface looks like. Some other friends are mentioning the white they're seeing. So yeah, we've got the white in our clouds covering up our view as well. But there is some white we can see here on the land as well, right? So we've got the ice up at our North Pole and the ice down at our South Pole covering the surface of our Earth. What else are some folks noticing? I see a couple people are mentioning the different land that you can actually see. So yeah, we can actually see our continent. So Earth's crust is broken up into these different sections, and we can see that going on here, looking at, for example, North America. Well, yeah, so hopefully some of those observations helped give you a sense of what geological features kind of look like when we are given the perspective of looking out from outer space. Now that we've taken a look here at home, I think we're ready to go ahead and fly out. So I'm going to move us a little bit further out into our solar system, a place we saw earlier in our night sky and that we just played a game with Holly here, our red planet, so the planet Mars. And you know what? Now that we're finally out here, before we get down with the science, I think this would be a really great time for folks to maybe take a quick snapshot, since you know what? How many times do you get to visit a different planet in a field trip? So I'm going to go ahead and bring things back over to Brian, who can help us out with figuring out how we're going to take a selfie here with Mars.
Hey, thanks, Fatima. I'm excited about this. I want people to comment in the chat. How many people already have a vacation photo at Mars? I will admit that I don't, but if you do already have a picture of yourself at Mars, let us know in the chat. If you don't and you want to get one, this is a perfect opportunity. I'm going to turn it back to Fatima in a second to make sure that the video is located right on Mars. But I want to remind everybody right now, grab a camera, make sure you have it ready. If you publish your photo to Instagram and tag Varsity Tutors and Pacific Science Center. Their handle is PacSci. We'll have all those instructions up on the way out. You will be entered to win that field trip to space with this planetarium software and the team from Pacific Science Center in Seattle for up to 100 of your closest friends. If you don't have that many, friends of friends are invited as well. So make sure you got those cameras ready while you're logging into your phones. Also should note that Pacific Science Center has plenty of field trips available on their website. We'll give you those instructions at the end, and through Varsity Tutors, all kinds of other exciting classes coming up. And if you just can't choose, I recommend VT Plus, where you can do this every day if you want to with different classes and things. So check that out. We'll have more instructions at the end. So with that said, let me turn it back over to Fatima's screen so we can get that picture, and yeah, take it away.
Awesome. Thanks, Brian. So yeah, we are back over here at Mars. I think I've gotten a pretty good shot here. So you should be able to see some different land features here. So this should be a pretty good spot for a selfie. So I'll give folks a little bit of time here. Take a look and see, get the good angles. And then maybe after a couple seconds here, I can fly us over to the west and we can maybe see a different part of the planet if you want to try getting a different background here. All right, I hope you got that shot. I'll go ahead and move us over to the other side of Mars, maybe get some different geological features in a selfie here. So here's another option for a background for y'all. All right, folks. Well, I hope you were able to get your snapshot souvenir with Mars. We will be taking a look at some other places in our solar system as well. So if you didn't get the perfect shot here, there'll be some more planets in a moment you can also try getting a cool image with. But while we're here at Mars, I think we're ready to start making some observations of our red planet, right? So what are some things you're noticing? What are some colors or shapes? Can we finally see maybe more signs of those different geological features we were talking about a moment ago? And if you have some observations you'd like to share, feel free to start putting those into the chat. So let's see, what are some folks noticing? Well, just like with Earth, I'm seeing some folks are mentioning the different colors they're seeing, it looks like. So yeah, a lot of folks are definitely noticing that red that we get the nickname for this planet for. So like Holly mentioned earlier, we have a lot of iron oxide here in the dust covering Mars. So there's definitely a lot of red on its surface. Some other folks though are mentioning that they're noticing some other colors though. So for example, we see some white here on the surface of Mars. Yeah, Mars actually has a north and south pole just like Earth, and at its poles, it has ice. Now, it's not going to be water ice like we have here on Earth. Instead, we've got some different carbon that's been frozen, and that's what's going to be hanging out the poles here on Mars. But still pretty cool to see ice at the different polar caps on another planet. Some other folks are mentioning the darker colors they're seeing as well. So more like grays and dark browns. And those different colors also help astrogeologists with figuring out what different materials might be present down on the surface. So again, for example, thinking of that iron that the surface of Mars is made of, when it hasn't been exposed to oxygen, it's actually naturally going to be more of a dark gray color. So we've got a lot of gray here on Mars as well. Some other folks, it looks like we're mentioning some of the different craters here. I agree. I am also noticing some craters here. Friends at home, are you thinking maybe we're seeing more craters here on Mars or more back over when we were looking at Earth? What are you thinking? More craters here or more craters at Earth? See, a few folks are thinking we have a few more craters here at Mars possibly, and you would be right. We can definitely see more of these impact craters on the surface of Mars, and craters are really interesting to geologists studying other planets. You see, these craters can actually help us with figuring out how old or new a surface might be. And that's because a lot of these craters formed around the same time during this period known as the heavy late bombardment. And so once these craters formed, they were kind of able to stick around here on the surface of Mars. So that's why we see so many of them. But if we think about Earth, for example, some of those craters ended up getting erased. And that's because our planet has a lot of current and ongoing geological activity that is constantly resurfacing the top of our planet. So if we think of, for example, volcanic eruptions and that lava that could potentially fill up a crater, or things like tectonic activity, so thinking about how earthquakes can cause our surface to get recycled. So a lot of that happened on Earth and made our craters disappear. But over here on Mars, we can still see signs of those different impacts. What are some other features folks are noticing looking here at the surface of Mars? Any other particular features that maybe we were talking about a little bit earlier, or any other shapes you might be interested in talking a little bit more about? I'm seeing one person has mentioned it looks like Mars has a giant scar. I think you might be talking about here, right here. It does kind of look like a scar. We have this scratch kind of going across the surface of Mars. Yeah, that is a really interesting observation. What we're looking at here is actually known as Vallus Marinaris. So it's a pretty big crack on the surface of Mars. It's actually so big, if we brought it here to Earth, it could stretch from the east coast of the United States all the way to the west coast of the United States. So pretty massive. And looking at its shape, we can actually figure out a little bit what it might have caused it. So I'm wondering for folks at home, what do you think might have happened here on the surface of Mars to cause this big crack? Any ideas? If you have some, go ahead and let us know in chat. So seeing a few folks taking a guess. I'm seeing a few friends are mentioning things like maybe water moving around. So yeah, thinking of, for example, like our Grand Canyon here on Earth and how that formed over a long period of time thanks to water. One interesting thing here looking at Vallus Marinaris is it's almost a perfect straight line, right? And if we think about water, it doesn't tend to move perfectly up and down, right? It kind of winds around. So it's not likely that this geological feature was actually formed by water moving around, but it is possible that another type of geological activity that we can see here on Earth could have been the cause of this. You see, on Earth, we have something called tectonic activity. It's going to be the activity that actually gives us earthquakes and creates fault lines, like the San Andreas fault we can see right here in parts of California. And we can see that when these fault lines form, they cause this huge crack that can sometimes usually be more of a perfect straight line. So a lot of scientists are wondering if maybe that is what caused this giant crack here on Mars. All right, I think we have a little bit more time to try making a few last minute observations. Over here on this side of the planet, are we seeing anything different compared to the other side we were looking at? I'm noticing one thing myself. I'm definitely not seeing as many craters over here. How about folks at home? Are you seeing something kind of similar? Is it looking a little bit smoother here maybe? I'm seeing a few folks saying, yeah. Yeah, we definitely don't have a lot of craters over here, right? Instead, though, I do see some really interesting looking features. One giant one over here, a little bit further to the east. I have a few more here on my screen. So I'm wondering if folks have any ideas what those features might be. I see a few folks are guessing maybe those are some craters. They could potentially look like craters, I agree. So they kind of look like they could be holes in the ground. I think one tricky thing here is we're not getting a really great perspective, are we? So it's kind of hard to see if this is really high up or really low down. So I'll go ahead and give us a clue. We're actually looking at some things that are really high off the ground. So does that help folks out a little bit? I'm seeing some more guesses. It looks like some folks are saying now we might be looking at some mountains, or I'm even seeing someone mentioning that name Olympic Mons. So if we remember what Holly was mentioning earlier, that super giant volcano, Olympus Mons, we've actually found it here on our screen. So right here at the very middle right here. So this is going to be that super massive volcano here on Mars. And it is huge, friends. So actually Olympus Mons is so big. If we brought it to Earth, it would be more than twice the height of Mount Everest. But not only is it super tall, it's also really wide. We could actually cover the entire state of Arizona if we brought Olympus Mons here to Earth. So with that in mind, it really makes me wonder, what did its eruptions look like? How did it get so big? Well, unfortunately for us, it is inactive, so we can't really make any observations of its activity. But I'm wondering if we might be able to use our observations of how volcanoes erupt here on Earth to try learning more about how Olympus Mons might have formed. And for that, I'm going to go ahead and turn things back over to my friend Holly, and she'll be able to share some more info on volcanoes here at home.
Awesome. Thank you so much, Fatima. It was really cool seeing some of those geologic landforms right there on the surface of Mars. And I agree. I'm really curious about that huge volcano, Olympus Mons. And I'm wondering if we can maybe figure out what type of volcano it might be. So in order to do that, we're going to talk about the three main types of volcanoes that we have here on Earth. So typically we have cinder cone volcanoes, shield volcanoes, and stratovolcanoes. So here's an example of a cinder cone volcano taken at Lassen Volcanic National Park in California. And these are the smallest, so they typically only get about 500 feet high. And what happens is, out of this volcanic vent, lava erupts out, shoots into the air, and it actually cools down really, really quickly and kind of rains down this hardened lava chunks that we call cinders. And those pile up around the volcanic vent, giving it this shape. Now, for our next two types, we're going to take a look with a demonstration. So what we have here is a model of our next type, a shield volcano. So go ahead and start sharing with me in the comments. What are some things that you notice about this shield volcano model? What do you see? Maybe about the size or the shape. I see some folks are sharing it. It's not very tall. Maybe looks a little shorter than you would expect. Someone said gentle slopes. That's a great description. I'm going to go ahead and start our eruption here in our shield model. So keep sharing with me in the chat. What things do you notice as we start our shield volcano eruption? Ooh, someone said oozing. That's a great descriptive word. I see that as well. Slow. That's right. Our lava is actually moving a little bit slower across the landscape. It's covering a really wide area here too. So I can see that the lava is slowly spreading out. It's moving even beyond the original area of our shield volcano. It's covering a really big amount of space. And the lava that comes out of a shield volcano has low viscosity, meaning that the lava is thinner. I like to imagine it kind of like an overflowing cup that just keeps spreading outward and outward. So again, it takes up a large surface area. And an example of a shield volcano here on Earth is Mauna Loa in Hawaii, which actually means long mountain in Hawaiian. So you can see here we've got our low viscosity lava that's oozing outward and creating a really big surface area covered in that lava. And Mauna Loa is actually the largest active volcano that we have here on Earth. All right, we're going to go ahead and take a look at our next type of volcano, which is called a stratovolcano, also known as a composite volcano, if you've heard it by that name. So go ahead and start sharing with me in the chat. What things do you already notice about the size and shape of this volcano model? See some great comments coming in. Taller, yes. Maybe taller, steeper sides. That's a great observation. Steeper walls. All right, we're going to go ahead and get our eruption started for this volcano. And remember to keep sharing with me in the chat what things you notice. Now, for this eruption, we actually are going to have a lot of pressure that builds up first in our volcano before the eruption starts. So we've got the magma underneath in the chamber that starts slowly building up more and more pressure before it erupts. Maybe make a guess of, oh, there it goes, folks. Go ahead and share with me what you noticed about this eruption. Someone said it happened really fast. I agree. In fact, it happened so fast that I'm going to play us a slow motion video of the eruption again so you can get a closer look. Share with me what you notice. Ooh, I heard someone say or saw that someone mentioned it's really loud, very explosive, much faster. That's exactly right. So in our stratovolcano, the lava is much thicker. It has high viscosity. So it's going to burst out really quickly in a really violent eruption there at the end. And composite volcanoes are made up of different layers. So it's not just lava that makes up this volcano, it's also layers of ash and mud flows called lahars that keep building up over the top of this volcano to form those steep sides. Because the lava is thicker, it cools down much faster, so it's not able to spread out as much as on our shield volcanoes. We're going to take a look at an example of a famous stratovolcano here. So this is Mount St. Helens, located here in Washington State, and it had a really big eruption about 40 years ago in 1980. And the ash from this eruption drifted all the way across the United States to the East Coast in just a couple of days. And in fact, some of the ash from this volcano made it all the way around the globe in the following couple of weeks. All right, folks, so now that we have kind of toured through these three different types of volcano, I want you to think back to that volcano Olympus Mons on Mars. So think about what type of volcano you think this is. Go ahead and share with me in the chat. Do you think it's a cinder cone volcano, a shield volcano, or a stratovolcano? I'm going to take a look here again and see if we can find some clues to help us find the answer. I noticed that this volcano, just like Fatima said, not only is it really tall, it's also really, really wide, has a large diameter, kind of similar shape to that Mauna Loa shield volcano that we saw from Hawaii. So that's right, folks. Olympus Mons is an example of a shield volcano out there in outer space. And you can also see here maybe why shield volcanoes get their name. It's kind of shaped like a shield that is laying over on its side, which I always see really clearly when I look at this picture of Olympus Mons. So now that we know some more about the different types of volcanoes, I'm really curious if we can maybe find some more volcanoes out there in our solar system. So let's head back over to our planetarium to see what we can find.
Thanks, Holly. I definitely think we should be able to find some more volcanoes here in our solar system. So let's go ahead and keep flying out. So right now I still have us at Mars where we left off. So let's go ahead and keep going further out in our solar system. So we're actually going to go into our outer solar system here. And the first planet we'll hit once we get out here is going to be the gas giant Jupiter. Again, we saw earlier in our night sky. So looking here at Jupiter, I'll go ahead and leave us here on this one spot if any other folks would like to take maybe a picture here with Jupiter. And while folks are getting their photos in, I would love to hear from friends at home. What are some things you're noticing here looking at the surface of this planet? Are you noticing some things that are similar to what you saw maybe when we were looking at our planet or Mars? Or are you noticing some different things here? I'm seeing a few folks have mentioned the colors they're seeing. So yeah, we've got some yellow and some white here on Jupiter. Those colors are going to be coming from the different gases we have in its atmosphere. One friend has actually mentioned that we're looking at kind of what looks like a marble here. So yeah, it looks really smooth, doesn't it? Actually, looking here at Jupiter, the entire planet looks really smooth, doesn't it? And that has to do with what it's made of. So Jupiter, we call it a gas giant. And so that means the planet is made of mostly a bunch of different gases. We don't actually know if Jupiter has what we would consider a surface that we could actually land on. So we can't really see a rocky surface like we saw on the other places in our solar system so far. And I don't know about y'all, but that makes me think it might be kind of hard to make some observations if we're thinking as geologists, right? Not really seeing the rocks and minerals here that we would be able to look for evidence of geological activity. But you know what? We don't have to go too far to find a place that might be a better option for a geologist. I'm actually just going to fly us over to one of Jupiter's many moons. So Jupiter has about 79 moons orbiting around it. So there are a ton of options for places we could go try to make some observations. And the one I brought us to happens to probably be my favorite place in our solar system. This is going to be one of Jupiter's largest moons, Io. So folks at home, what are some things you're noticing here, taking a look at this moon of Jupiter? What are some colors you might be seeing? Does it look similar to anything else we've looked at so far? Are you noticing maybe any signs of some geological features we're trying to track down? A lot of folks are mentioning kind of the yellowish, orangish, greenish color we're seeing. Yeah, Io has some pretty interesting colors on it, doesn't it? A few folks mentioned the little black spots we're seeing here, so wondering what those might be. Great observations. What else are folks noticing? I'm seeing a few folks are mentioning maybe the black spots might be craters. That's an interesting idea. You know, looking here on Io though, I'm not sure if I see a lot of craters. Definitely not the amount we were seeing over on Mars just a moment ago. Honestly, the planet's looking pretty smooth. And if we remember, when we're finding craters on places, that can help us tell if a surface is really old or not. So I'm wondering if we can maybe take a closer look at some of these observations we're making to try to figure out what's going on here on Io. Let's start off with those colors everyone was noticing. So we saw a lot of yellow, a lot of greenish orange. Well, that yellow can tell us something really interesting is happening here. And we can actually see that yellow in certain parts of the Earth as well. If I bring us back here just for a moment, we can see this really yellowish looking color here on the surface of this bank in a national park in Hawaii. And this yellow is actually being caused by an element known as sulfur. So sulfur is going to be a chemical that's pretty stinky. It kind of smells like rotten eggs. But the cool thing about it is it actually gives us a really good sign of some volcanic activity. So here on Hawaii, we're actually looking at the Volcanoes National Park where we have these large sulfur deposits. If we come back to Io and take a look at that yellow, we can see it is all over the surface. And satellites that have flown by this moon have been able to actually analyze the minerals we have here and have found a lot of sulfur shooting up from the surface here on Io. So that's one good sign of some volcanic activity happening here. And if we go back to what folks were saying also about maybe looking for craters, and I was kind of noticing it seemed a little bit harder actually to try to find some of those craters. That's going to be because we have volcanic activity actually happening here indeed. Io is going to be the most volcanically active place in our entire solar system. So it's covered in hundreds of volcanoes that are constantly erupting. We've been able to see some of these eruptions happen flying by the moon with a satellite like Galileo recently did. And so we were able to capture some of these eruptions that are just super massive, some of them getting as high as 200 miles off of the surface of Io out into outer space. So learning about what caused some of these observations we were able to make, we can understand a little bit more why Io looks a little rough here. It looks a little beaten up, doesn't it? That's going to be because of just all of that volcanic activity going on. So Io is a really great example of a place in our solar system where we have a lot of really hot activity happening. But we do have a little bit time left in our program, so I think we can try checking out a place that is going to be the exact opposite. So I'm going to go ahead and take us out even further into our solar system here. And for our next place, we'll just go ahead and get to our next planet. So this is going to be our ringed planet, Saturn here, which looking at it, we might be able to quickly make some similar observations to what we saw at Jupiter. So the surface of Saturn itself looks really smooth. And that's because once again, we're looking at a gas giant. So we don't really have a rocky surface to make observations on. I see a couple folks are mentioning maybe we can make some observations on the rings. Yeah, the rings definitely would be made up of some particles the geologists might be interested in. So for example, thinking of some rocks and chunks of ice. But you know what, while we're out here, I do have a better place that might be a little bit easier for us to get up close and make some geological observations. So just like with Jupiter, I'm gonna go ahead and fly us over to one of Saturn's moons. And this one is going to be called Enceladus. So looking here at Saturn's moon, what are some things we're noticing about its surface compared to what we were just seeing over at Io a moment ago? A few folks are mentioning it looks really white. Yeah, so we definitely don't have that yellow we saw in Io, right? So not a lot of sulfur on here. I'm seeing a couple questions about what this stuff is. So these kind of like, it looks like fountains or geysers coming off the side of Enceladus. That's a great question. Those might be some signs of some type of geological activity going on here. What about looking at the shapes and features we can see on the surface? Are we seeing a lot of those craters that we keep trying to find, or are we seeing some different features here on this surface? A few folks are mentioning seeing some craters. Yeah, maybe more on this side. So we definitely have some craters here on Enceladus, but what if I bring us back over here, kind of closer to those geysers we were wondering about? Do we still see a lot of those impact craters here? Some folks are saying no, it looks a little bit smoother. Some folks are asking if this stuff looks kind of like a river, maybe. We're seeing these kind of scratches. Yeah, what we might be noticing here are going to be what scientists have informally nicknamed the tiger stripes of Enceladus. So these are going to be marks on the surface of this moon that we're thinking might have been caused by the movement of giant oceans of water. You see, scientists are really thinking that there might be bodies of oceans just underneath the icy surface of Enceladus here. So that movement is going to be causing these cracks we can see. And these plumes we can see over here on this side of Enceladus are signs of something really cool happening with that frozen ocean. You see, here on Enceladus, we do have some volcanic activity, but it's not going to be the hot volcanic activity we've seen so far in all the other places we've ventured around. You see, on Enceladus, we have something called cryovolcanoes. So these are working a little bit different. Instead of shooting out hot molten rock like we saw over on Io or taking a look at places here on Earth, the volcanoes on Enceladus are so cold, and they actually shoot out things like frozen ice, vapors of water, methane, so really freezing cold stuff. And you know what, with that, I think we might have just hit every possible variety we know of so far about different volcanoes we can find here in our solar system. And I would just like to say, I am so appreciative for getting to join the group today. It was so much fun getting to take a look at these different places in our solar system. You know, if you had a lot of fun making those observations with us today, I would really love to encourage folks at home to continue trying to make these observations on your own. Remember, we gave you some really great tips on how to use that ecliptic, that path the sun was taking to try to track down some of those visible planets in our night sky. And also for more ways to stay curious at home, please feel free to check out PacSci.org. We've got a bunch of different activities available for friends and family, including information on how you can sign up for your own virtual field trip and have some fun learning more about STEM. Before we go though, Holly and I are going to stick around for just another moment, and Brian's going to come back to help us out with a quick Q&A session. So we'd love to hear some more questions from friends at home. So I'll go ahead and pass things back over to Brian here.
All right, thanks to both Fatima and Holly. I know my jaw was on the floor looking at Io and getting that tour of space, and especially when the that last volcano erupted. That I jumped, I kind of screamed a little bit. So I'm sure everyone else at home did too, and we learned a lot. This was fantastic. Also, thanks to every one of you out there for asking so many good questions. We have, where to begin. I think the one that everybody really wanted to know is for you, Fatima. What program are you using to be able to tour space like that, and how can we do that?
Yeah, great question. So I was using a program known as Stellarium at the beginning. So when we were looking at the sky, and that's a really great free open source tool that folks at home are able to access and use to get into astronomy. So once again, that was Stellarium. And then the program I was using to fly around to the different places in space, that is going to be NASA Eyes. So another free tool available. So if you just search up NASA Eyes, it'll pop up and it's available for folks also at home to be able to use.
Actually, that is amazing. I forgot to take myself off of mute because I was quickly running over to try to get into NASA Eyes. So it's if everyone else is doing the same, I know I'm not alone. So thank you for that. Just amazing stuff, and help to have an expert tour guide as it so often can. We also know one for you, Holly. Fatima told us that her favorite place in the solar system is Io, and told us all about why. Do you have a favorite place in the solar system, and why?
Ooh, favorite place in the solar system. That's a great one. I mean, I love Earth, but I won't say that one. My favorite place is actually Cassiopeia, the constellation. So it's made up of a few different stars, but I like it because it's really easy to find in the northern hemisphere all year round. And it's shaped like kind of a wonky shaped sideways W. So I always love looking for that constellation Cassiopeia up in the sky. Maybe you can look for it as well.
That's great. Thank you. I appreciate that. It actually leads into another question for those of us who struggled a little bit. I think you saw across social media and talking to friends the last couple of weeks, people saying, I missed it. I wanted to see, the intersection of Jupiter and Saturn, and I missed it, or I wasn't sure where to look, or it was cloudy. What advice do you guys have for those of us who like looking up at the stars and wish we understood more about what we were seeing, or wanted to be able to go and find things that we really wanted? What kind of advice could you give amateur stargazers for how to make better use of our time looking up?
Yeah, that's a great question. I know I was super frustrated too. I did not get a good view of Jupiter and Saturn. It was way too cloudy here in Seattle. A big part of astronomy is definitely patience. So unfortunately, that might not be the best advice, but sometimes you really just have to luck out. Thankfully, though, there's always a lot of cool stuff happening in our sky. So if you didn't catch the stuff happening just a moment ago in December, this year, we also have a lot of cool things happening. So constant meteor showers, the planets are always doing something strange. So space is just a cool place. So there's going to be constant events going out there to try to find. I will say trying to get started with astronomy can definitely kind of be intimidating. If we come back in the planetarium, one thing I would say is really helpful is just really trying to get your bearings in the night sky. And so doing that, you can actually use some constellations to help map out the sky. For us here in the Northern Hemisphere, I really recommend folks trying to track down the Big Dipper. So you can find it pretty easily here in the US. As long as you're north of the equator, it'll be visible. So I've got the Big Dipper right over here. So it's going to be about 7 stars. Finding a good anchor in the night sky and then just kind of jumping off from there to help map out the rest of your constellations, that's actually exactly what astronomers are doing. So the constellations don't have any real science behind their shapes, but they're really useful in science because we kind of use them as a map. So that would be my big tip for getting started with astronomy is learn how to map out your sky by using those constellations to help orient and navigate yourself around.
That's terrific. Thank you. That's sort of, I guess you can't call them landmarks, kind of like we can't call earthquakes on Mars earthquakes, they're Marsquakes. So, maybe star marks, but just like you would find out, kind of learning your way around your neighborhood or a new city or something, find a couple landmarks to anchor yourself, and then you can start to branch out from there. So I think is pretty amazing advice. So thank you. I know I'll be using that. I think it's a pretty clear day out here. So hopefully I'll get a chance to put some of that to use. One other is we take a tour of the solar system. One other that came up quite a bit, and I as someone who studied the planets a few years ago, this one is personal for me too. But a lot of people were asking, can you tell us why isn't Pluto a planet anymore? And is there a chance to get it back?
Oh, I get this question so much. I think the demotion to Pluto actually talks a lot about some cool stuff that happens in science. So sometimes we learn new things and we have to reconsider what we know, right? So with Pluto, we had a discovery in our solar system of some new objects. And we didn't know what to call those objects. They weren't really planets, they weren't really asteroids. And so we had to rethink what was going on. And we ended up coming up with the term dwarf planets. And that sort of had a spiraling effect that ended up affecting poor Pluto, where when we were trying to define what makes a planet versus a dwarf planet, suddenly Pluto wasn't really meeting the things needed to make a planet happen. In particular, Pluto wasn't clearing its orbit. So it's not big enough to throw things out of its way as it's moving around the sun. And so that was the big thing that kind of sank poor Pluto to the status of dwarf planet. But it could be considered sad for some, but for me, I think it's really exciting because it just kind of talks about how we're still discovering so many things. So we can't really be rigid in our definitions or talking about space.
I love that, actually. Yeah, we lost one planet, but because we gained so many other dwarf planets, we found so many new things. We needed to find new names for all of them. So I'll take that. I like that optimism too. Thank you. That's really exciting. All right, for those of us who like legitimately like screamed, gasped, ducked for cover when the volcano went off. I know a lot of people are wondering, do we know where all the active volcanoes are, or could something like that on Earth sneak up on us today, tomorrow, sometime, anytime soon? So do we think we know where all the volcanoes on Earth are?
Yeah, that's a great question. So we're definitely much better prepared now than we were a long time ago, hundreds of years ago. Scientists estimate there's about 1,500 active volcanoes worldwide, but only about 500 of those have actually erupted in our recent history that we know of since humans have started documenting history. So 500, seems like enough that we could hopefully keep tabs on most of those. So the volcanoes that we know are more likely to be active, seismologists, geologists, other scientists are monitoring those really carefully. For example, maybe some of you heard about the volcano Kilauea that just had a really recent eruption about a week and a half ago over in Hawaii. So they're really closely monitoring those, especially volcanoes where people live really close by. So to give people that heads up that, hey, we need to evacuate to keep everybody safe. That being said, nature does what it wants to do. Sometimes they're really unpredictable. Even like our experiment here, even though I knew it was going to erupt, it still kind of caught me by surprise, other folks by surprise. So we definitely need to be really careful and just mindful that things can change. And that's what part of what keeps this science really interesting and exciting.
Nice. Thank you. I'm glad for the most part we can be pretty confident. And I do like that science throws in some surprises for us every now and then, gives us new things to research and learn about. Speaking about learning about things, a lot of questions came up about the field trip contest. So is it true that I can really invite that many people? Can I invite my whole class? And I think the answers to those are, yeah, you can invite up to 100. And as long as your class is up to 100, you can invite them all. Can you tell us a little bit more about some of the other field trip opportunities that Pacific Science Center has available for everyone, or what they can expect to learn if they win the Instagram contest, which again, for everyone, those rules will be up on the screen in a few minutes on our way out. So you know exactly what you have to do.
Sure, I can jump in. So we have about 9 different topics of our virtual field trips. They're really awesome. You can do them from any remote location. So yep, you can invite up to 100 of your friends or classmates, or if you have a scout group or maybe some family members, maybe you want to do a virtual birthday party, and we will join you remotely and share with you the really awesome things that we have. They take about 40 minutes and we do a lot of interactions. So again, we'll ask for your questions and your responses in the chat. We'll even have opportunities for you all, you and your friends, to be able to unmute, share your questions and observations with us out loud, and explore those things together. So we've got topics like our planetary geology, kind of what we did today. We also have our night sky tonight virtual planetarium. So if you're more curious about finding those constellations, how to find the North Star, hearing some myths about our constellations in our night sky, that would be a great fit for you. And we've got a new program called Robots on Mars. So if you didn't get enough about our red planet. We do have a program that specifically talks about those robots and scientific missions that are going to Mars to help us learn more about it.
Thank you. Yeah, some amazing things to learn. Hopefully everyone got inspired today to learn more about space, about geology, and I'll also put in a plug. Through Varsity Tutors, we've got tons of these classes coming up on all kinds of topics. If you like dinosaurs, we've got classes like that next week, all kinds of things to get excited about. So if you like learning, I think there's never been a better time in world history to explore all of your different passions with Pacific Science Center and of course with Varsity Tutors. So last question for you guys. We had a lot about people recognizing that what you're doing is fun, and people wanted to know, how do you get a job like yours? I don't know if you have a quick minute to how did you get to be so lucky to tour space and blow up volcanoes for a living?
Yeah, I could take part of that at least. I don't know, for me, it really just started with constantly being curious, asking lots of questions. I grew up watching a lot of documentaries for fun. That's how I spent my free time. And that just led to me wanting to kind of seek out those opportunities to find a career where I could be asking those questions professionally. I know one really great way to get started. Also, for example, thinking about like volunteering maybe at local museums when we start opening back up, or finding some opportunities that are happening online right now to kind of informally get in. And from there, just building that experience. But really, it's just about asking all those questions and finding those people who are curious. Holly, do you have anything else you'd add?
I agree, Fatima. It's really great to be able to just share the things that we really enjoy learning about with other people. So part of what I like best about doing this type of work is being able to connect and communicate with other people, from young kids all the way up through adults. And so another way to get involved with this type of work is just start sharing your ideas and thoughts with other people. Maybe volunteer at a summer camp, a Boys and Girls Club, places like that where you can get to just start communicating with people, build those relationships, and sharing those really fun ideas, sparking curiosity in other folks.
Perfect. Thank you, guys. I'm glad you found your callings, because it was certainly really beneficial for all of us here. So a huge thanks to Fatima and Holly and everyone at Pacific Science Center for all the the amazing tour, all the information, all the enthusiasm, and everything. Huge thanks to all of you for all of your questions, for in advance for tagging Varsity Tutors and Pacific Science Center in your selfies. That's always one of our favorite parts of these classes in this series, is as getting to see people actively learning and enjoying all that. So I'm going to put up right now the instructions for the contest, and also some more information about where you can find out more about the programs at Pacific Science Center. Like Fatima and Holly mentioned, whether it's virtual field trips or kind of, self-guided learning opportunities and projects and things. And also, of course, Varsity Tutors, like they mentioned, it all starts with curiosity. Whatever you're curious about, there are ways to learn about that through Varsity Tutors. So check us out there. And huge thanks to everyone for all of your participation. And we'll see you back for one of these events here soon. So and before that, we'll see those pictures on Instagram. So huge thanks, everyone, and we'll see you again soon.